Hey guys, go ahead and get out your note sheets for 8.1 and 8.2. We'll take a look at 8.1 first and then go straight into 8.2. Alright, so we're going to take a look at adding and subtracting polynomials in section 8.1, and polynomials can be classified in different ways. So one of the ways you can classify a polynomial is by a monomial, and monomial, if you look at the prefix of it, would mean one, so it's one part. And so we've got two different examples here, and you can add an example and put the word one on your note sheet if you want. But monomial, this is one big group of numbers being multiplied together. This is one group of numbers being multiplied together, which makes it a monomial. Another classification for a polynomial is a binomial, and the prefix bi means two. So if you take a look at this, these are not one part anymore. This is two parts because they've got that separation with a plus sign or a minus sign. So you can put one of those examples with two on your note sheet. And then we can also have a trinomial. And trinomial, again, that prefix tri means three. And if we take a look at these examples, there's three parts in each of these. So monomial, one, binomial, two parts, trinomial, three parts, and basically what makes it different parts is that separation with your plus or your minus sign. So to describe a polynomial then, a polynomial is basically a generic name for any kind of term with one or more parts. So polynomial could have described actually all three of those, the monomial, binomial, and trinomial is kind of more of the generic name of this kind of problem. But it also can describe an expression that has any more than three parts. So once we get beyond trinomials, if you have an expression with 4 or 5 parts, it's just called a polynomial at that point. So another way you can classify polynomials is talking about the degree. So we can talk about the degree of a monomial, which is that one part kind of expression, and a degree of a monomial is found by the sum of the exponents of the variables. So you would look at all of your exponents and add all of those different values together in a monomial. So in this first example for 5x squared, if somebody was to say what is the degree of this monomial, it's only got one exponent in the x squared, so the degree is that 2 only. And the second expression, when you look at your exponents, we actually have 3 exponents with 3 different degrees, so the degree would be adding up each of those exponents, which would be a degree of 8. And then in this third example, there is no exponents, there's no variables, so the degree would be 0. So we just looked at how to do the degree of a monomial. We're really going to work with polynomials a little bit more. So finding the degree of a polynomial is a little bit different. And so to name polynomials officially, you would need to know the number of terms they have. So you can name it as a monomial, binomial, or trinomial, or more would be a polynomial, and also the degree. And the way you find the degree of a polynomial is by looking at the largest degree from the terms in the polynomial. So you look at each individual term, and you look for whatever one has the largest exponent, and that's how you would state the degree of that. So let's take a look at how to name these different polynomials that you've got here. So the first one, you would look at how many different terms does it have. So I see 3 different parts or terms here, so that makes it a trinomial. Next is you look at what's the highest degree or the highest exponent, and the highest exponent is that 2 with the x squared, so this would be called a second degree trinomial. Second example here, so I'm looking at how many terms or parts. It's 2 parts, so that's binomial. And then what's the biggest degree or exponent you see? It's that cubed with your first term, so this would be called a third degree binomial. So naming them all comes down to how many parts they have in the highest degree. So go ahead and pause and see if you can figure out how to name this polynomial that you see up top, and press play when you're ready. This example here should be a 5th degree polynomial, so there's more than 3 parts, which just classifies as a polynomial in general, and the highest degree is that 5th power, so 5th degree polynomial. Okay, so we're about to look at how to add and subtract polynomials, but before we do, I want you guys to just get used to what standard form of a polynomial answer should be. And standard form would be in descending order, and descending order by your exponent value, so by that degree. So we've got a couple examples here. If you were to actually redo these in descending order, and the proper way of showing something like example 1 here would be that highest exponent first, so x to the 4th. Then minus 3x squared plus 8x minus 4. So this is just rearranging it to be in a proper standard form with highest degree to lowest. Second example, putting this into order based off of the x terms. So you're looking for the highest degree for your x terms. So the highest that I see right now is that x cubed followed by x squared. This would be an x to the first, and then you have no x in that other term right there. So if I wanted to put this in your standard form, it should shift and look like this. So now we're actually ready to kind of jump more into polynomials and look at how you can add and subtract them. Your rules for adding and subtracting polynomials are actually pretty easy. It's pretty much combining like terms, so this is kind of just re-emphasizing that. And basically you can only add and subtract like terms that have the same variable and same degree. So it has to be x squared to put it with another x squared. Another thing to keep in mind is that when you are adding like terms, you keep the sign in front of the term, and then you're either adding or subtracting with any other like terms that you see. So you always want to look at that sign in front. Don't lose that. You always keep it with it so you know if it's a positive or a negative. And then lastly, do not change the degree of the exponents. They will stay the same. If I'm adding x squared with x squared, it's not going to become an x to the fourth. It's just how many, 3x squared plus 2x squared would be 5x squared. You're just adding the number in front. So we've got your first example here, and again, this is really just looking at kind of a way of combining like terms. People like color coding, or sometimes I do underline or circles. You're really just going to look at this problem and look for all your like terms. So I've color coded, and then you're going to go ahead and just write your final answer with combining everything. And standard form would be, again, highest degree to lowest. And so this final answer here would be 3a squared plus 7ab, since you combine those through the 3 and the 4ab's, and then plus 5b squared. And the reason why it's this order for that is because I'm going by highest degree based off of your a's. And then I know we have a b squared, but we're going by degree from a. Second example, again, I'm just really looking for like terms, so I'm going to combine anything that's the same. So I color code, or you can underline or circle or highlight, and then I'm going to go ahead and just add or subtract these as is. So 3a squared plus 4a squared is 7a squared, and then negative 2b plus 6b is 4b, and that would really be it. You can't do anything else to simplify. So example 3 here, I've already gone ahead and I kind of made a little code for myself to look at all the like terms, and I'm basically just going to combine them. So in example 3, 2a squared and 3a squared is 5a squared. My red underline is negative 1ab plus 5ab, which would be positive 4ab. My black underline is a b squared. I'm actually going to hold off on that because I'm still going by degree for a, so I'm going to make my minus 7ab squared next, and then end this with plus b squared that doesn't have an a at all. Now, these middle two could probably be changed out since they both have a degree of 1 for a, but so that order doesn't really matter, but everything else here looks good to go. Example 4, so circled in blue are my x squareds, which should make 7x squared, and then 3x minus 4x is minus 1x, and then minus 3, and that would be your final answer from that. Nothing else you can do. So pretty easy, just combining like terms for this. Okay, so if you haven't noticed, those were all addition examples. So we're going to take a look at subtraction, but there's something to be careful with subtraction. And so what you want to focus on here is when you're subtracting a polynomial, make sure you subtract the entire polynomial or distribute your negative to everything that's being subtracted. If you have an entire group in parentheses that's being subtracted, then all of those parts are subtracted, not just the first part. So you want to definitely be careful for this. This is typically where people make their mistakes. So our subtraction examples, the first one here, again, we're saying that we have this whole group of parentheses at the beginning, and then we're subtracting everything else that's on the right-hand side. So we have to distribute that negative to all three of those, and I would suggest definitely rewriting it with changing those signs so that you can actually see the sign that goes with each, and then now we can look for combining like terms, and you can either color code like this, or highlight, or circle, underline sort of thing, and then you're just going to go ahead from there like you're adding and just put everything together that's a like term. So 6w squared minus 4w squared is 2w squared, negative 5wz minus 6wz is negative 11, and then negative 3z squared plus 8z squared is 5z squared, and that would be it. Second example, so same thing, we actually need to show that we're distributing that minus sign to both things in parentheses, so that becomes minus p squared minus 11, and then you can color code some sort of way if you prefer, or underline, highlight, and then combine your like terms. So 7p minus p squared is 6p squared, negative p all by itself, just negative p, and then negative 7 minus 11 is negative 18. Go ahead and try number 3 and see if you can get it, and then press play when you want to check it. Final answer here should be 5x squared minus 11x plus 6, and again, you distribute that negative and rewrite your signs, combine your like terms, and you're good to go. And go ahead and try number 4, and it should be one of these 4 answers, so hopefully you get one of those, and press play when you're ready to check. And final answer should have been 3a minus 9b. Again, distribute the negative, combine your like terms, and then you're good to go. So the last thing we're going to look at is finding the perimeter of each of these shapes, and again, people kind of freak out when they see this, but really perimeter is just adding all of the outsides. So this is just saying to add all of the outsides of the shapes that you see here, which is really just combining like terms. what you want to be careful with is with your rectangles is that you don't forget that rectangles are not just the two sides that you see, but they're four sides. So I would suggest writing in on the opposite sides those same values so that you can find your perimeter by adding all of your like terms around. So we've got x plus another x plus 3x, which is going to give you an 8x. And then we've got that 6 plus 6, which is 12, minus 5, which is really like 12 minus 10, and that's going to be 2. So your final perimeter here would be 8x plus 2. Your triangle is actually a pretty easy one because you don't have to fill anything else in. It's just 4x plus 4x, which is 8x, plus the 9 that's there by itself, and that would be your perimeter. Go ahead and try the last two. So again, don't forget to do all four sides, and then you can press play when you're ready to check. So your third example, you should have ended up with a perimeter of 6x squared plus 2x plus 2. And then your fourth example should end up being 4x squared minus 2x minus 12. So that's really it for 8.1. It's just pretty much adding like terms or subtracting like terms. So we'll go ahead and take a look at 8.2 now. Alright, so your steps for multiplying a polynomial by a monomial is very similar to just plain old distributive property. So distribute the number outside of the parentheses, but you have to just be careful because we're going to have, a little bit more going on with variables. So multiply the regular bases, numerical bases. 4 times 4 is still 16. But whenever you have variables that you're multiplying by other variables, according to the laws of exponents, you're going to add those exponents. So we're kind of using laws of exponents and distributive property here at the same time. Step 2, rewrite your answer in standard form. Standard form would be your largest degree to lowest degree like we just looked at. So we'll start with a really, really easy one since this is just plain distributive property. This will be 5 times 7n, which is 35n. This is no different than earlier this year. And 5 times negative 2, negative 10. Final answer done. Second example is where we're going to have a little bit more going on with your laws of exponents. So we've got 3/4 a times 8a. This is still just 3/4 times 8 and then a times a. So 3/4 times 8 would be 6, and then a times a, we're really going to add those two exponents, creates an a squared, and then we're going to distribute to 12 as well, and 3/4 of 12 would end up being 9. And at that point you would be done because that's already in standard form. Example 3, so we're going to distribute. So it's your regular numerical bases would be multiplied. That would be 6 times the 1 that's not showing there, so that's still 6. But then we've got r to the first times r to the second. So we're going to add those two exponents, which creates r cubed. And then we've got s times s, and that would be s squared. So that's your laws of exponents because we're multiplying those same bases. We're going to add those. Next, it's 6rs times negative 3. So the only thing we could truly multiply here is the 6 and the negative 3, which is negative 18. And then rs, there's nothing else to combine those with, and this would be your final answer. Example 4, distributing. So 4 times 3 first is 12. T squared times another t squared. We're going to add to get t to the 4th. Your middle term, 4t squared times 2t makes 8 for your number, and then t squared times another t is t cubed, and then lastly 4t squared times negative 5 would be negative 20t squared since there's no other t bases to do anything with. And then example 5, so number-wise, negative 4 times negative 3 is 12. Variable-wise, you've got m to the 3rd times m to the 1st, which you're adding to get m to the 4th. Middle term, negative 4 times negative 6 is 24. And m and n cannot be combined, so in this case you actually just keep them separated. And then your last term, negative 4 times positive 4 is negative 16. And again, m and p cannot go together, so we just write them as two separate bases, and that would be your final answer. Number 6 is always one that throws people off initially when you look at it, but if you think about it, it should not be too bad. So it's not really negative x over 3. I mean, it is, but you can put your number in front of x, which is 1. So ultimately what you're doing here is you're distributing a 1/3 x. So as we go through, we need to be thinking about that as 1/3 x, not necessarily x over 3 and a negative. So negative 1/3 times 27 is just like 27 divided by negative 3. That's negative 9. And then you've got an x times x squared, which makes x to the 3rd power. The middle term is negative 1/3 times negative 6, which should be a positive. And again, that's really like 6 divided by 3, which is 2. And then that's an x times another x, which is x squared. And lastly, negative 1/3 times 12 should be a negative 4. And then there's that 1x with the 1/3 that's still going to be part of your answer. So And at that point, you would be done with this problem. So not too bad once you realize it's really just a 1/3, not x over 3. That tends to throw people off. All right, go ahead and try number 4 on your own and see if you can come up with it, and then we'll take a look at this and you can press play when you're ready to check it. All right, so we haven't seen one like this exactly yet, but you would distribute in the first group and get 12y cubed minus 4y. Second set just remains plus 2y cubed minus y. And then if you didn't realize, this is actually now looking at section 8.1 where we have these like terms that we can put together. And because these are both y cubes, we're allowed to add 12 plus 2 to get 14y cubed. And then negative 4y and a negative 1y would be negative 5y. So the answer to this one should be option 4. So problems like these are basically combining, multiplying first and then combining like terms if they're there. Go ahead and try number 8, and then you can press play whenever you're ready to see what the answer is. So your final answer for this one should be option 1, and really this was just testing that you're adding your exponents correctly with each of the bases that are the same as you're multiplying. And again, the last thing we're going to look at is your shapes, because these are very popular problems. So this one says determine the area and perimeter of each shape. So we've already looked at how you do perimeter. Area, because these are both rectangles, is just length times width. So it's going to be kind of applying what we just looked at in this section. So we'll go ahead and knock out perimeter first because it's a little bit easier. So your first shape for your rectangle, your perimeter would be adding all 4 sides, which gives you 4x squared plus 2x minus 8. And again, we just looked at that in the last section. And then your area, I have it set up, would be length times width. So it's 2x squared times x minus 4. And to simplify that, we're just going to distribute. So this becomes 2x cubed minus 8x squared would be your final area. And you would be done with that one. So still not too bad to do perimeter and area. Next shape, since they only give you 4x squared, we can probably assume that this is a square. I know you never want to assume, but this is a square, I will tell you that. So when we're doing perimeter, we're doing 4x squared plus 4x squared plus 4x squared plus 4x squared. So you're just adding the 4, 4, 4, and 4 to make 16x squared. Pretty easy perimeter. And then for your area, you're going to go ahead and just do 4x squared times another 4x squared, which is actually going to look more like our laws of exponents. So 4 times 4, 16. X squared times x squared, we're going to add those exponents, and we're going to get 16x to the 4th for your area. And that would be it really for these shapes. So just be cautious of these and be aware of these problems. They really shouldn't be that hard if you actually just think about how you do perimeter and area for them. The back of this page is going to be extra practice. We'll do that next time I see you guys in class. So that is it for your notes, and I will see y'all soon.